Okay, so follow along here, guys. The best test for determining whether an unknown compound is ionic or molecular would be to test what? The conductivity. I'll just accept conductivity. I mean, it is supposed to be the conductivity of the solution, but conductivity is fine, so fill in the blank. So, okay, we'll accept that. Okay, number 2, if something has a pH of less than 7, it is A or N, because the two answers would require different, what is that? I don't know, some English term, pronoun or something, I don't know. What is it? Acid. Okay, number 3, you add a sample of an unknown compound to water and the solution turns blue. What metal does the compound contain? Sadie. Copper, right. Okay, give the names of the following compounds. All right, this has got a metal in it, so it's ionic. Okay, all we have to do then is fill in the ionic rules. Okay, since it's calcium, it only has one possible charge. We don't need any Roman numerals. All right, so calcium nitrate. Okay, for number 5, I've got 2 nonmetals, so I'm going to need prefixes. Disilicone, okay, trioxide. Questions on either of those? No? Okay. Number 6, I've got lead and oxygen. Lead, however, has more than one possible charge, so what will I need in the name? Roman numeral. So I got to figure out which one. Since oxygen is always -2, I have 4 negative charges here. I only have 1 lead, so the charge on lead has to be +4. So we're looking at lead 4 oxide. Okay, everyone with me there? All right, and number 7, okay, we've got potassium and phosphorus, so it's an ionic compound, simply potassium fluoride. Sorry, phosphide, fluoride. Phosphide. Hey, come on, they both start with F. No, they don't. Okay. Then for these ones, give the formulae for the following compounds. Sulfur dichloride. All right, that's molecular. It's got a prefix in it, so that's simply going to be SCl2. Okay, magnesium phosphide. Ionic, so I got to do the drop and swap. Magnesium is +2. Phosphide is -3. Drop, drop. Mg3, P2. Okay, and number 10, cobalt-2 nitride. So what does the 2 tell us? Cobalt's charge. So CO2 plus, nitride -3, CO3 and 2. All right, to number 11, sodium carbonate. Again, ionic. Sodium is +1. Carbonate is -2. So the 2 comes here, the 1 goes there. Since I don't write 1s, I don't need brackets. I can leave it as Na2CO3. All right, so what are we looking at here? It's out of 11. So give them a mark out of 11, put it on the top, let them see it, and then please put it in the box up here. So for these tests that we want to run, okay, the tests that are going to need to be in your procedure, and in your procedure you need to tell me, first off, you know, what I'm going to do when I first come into the lab. Okay, how do I prepare to do this lab? Okay, what things do I need to get and bring back to my table? All right, and then you need to talk about each test. Okay, and you can't just say perform observable properties test. Okay, you need to be more specific than that. Okay, maybe have a part A, B, and C where you're describing what things you should look for. Okay, you also need to make sure that you have the procedure written in the right order. All right, we said there's an order that you need to do these tests in. Okay, because if you do one, it could screw up the results for the others. We don't want that to happen, so that's other things you need to think about. Okay, now obviously, okay, your first test, observable properties. If I'm looking at this stuff, okay, you know, it's got very small, you know, white crystals, okay? Doesn't appear to have any odor, all right? It's, the crystals actually look kind of spherical, but they're very small. It's hard to tell, okay? that would be about all I could say about it, okay, to start with, doing an observable properties test. All right, what would I do next? Okay, probably do a solubility test next, okay? So I'd make sure I take some distilled water. Now, just to make sure that it is distilled, I'll show you here with the conductivity testers, right? And they're starting to get really beat up, as you can see the battery kind of wobbles on them now. All right, when you press the button, you'll know if the battery works because there's a little on light. Okay, to make sure, because our other ones, they didn't have that, and sometimes the battery was dead and you just thought everything didn't conduct. Okay, so when you put that in, okay, you can see here, 1. All right, like distilled water has got basically no conductivity. All right, the longer you leave it in there, obviously, it starts to bring up the numbers. Okay, so you want to leave it in too long. All right, so I've got a 1 there. Know that that's definitely distilled water. Okay, if I add it, and you won't be using this much of everything, but okay, I give it a little bit of a stir. You'll use a stirring rod tomorrow because you won't have one of these. You'll be using a depression plate. Okay, it's called a depression plate, not because it's sad, okay, but because it has little depressions in it. Okay, sometimes also called a spot plate, but I can't make any jokes about that. So, okay, you're not going to use very much of everything. Agreed? Okay, pretty small samples of everything. Luckily, the conductivity tester fits very nicely in the little depressions. Okay, it all works very well. All right, that stuff I would have to say is pretty highly soluble. Yeah, I didn't add very much water, and it's pretty much all gone. All right, so now I want to find out if it's ionic or molecular. So I stick my conductivity tester in there. Of course, I would have rinsed it. Okay, in the lab, I would have rinsed it between. But all right, ionic or molecular? Probably ionic. I mean, it's got a conductivity. Well, it went up to 7 initially. Okay, I would say that's definitely ionic. If it's molecular, it's going to be like 4 or less. Okay, and most of the time it's going to be like 2. All right, if it's molecular. Anything above that, you're looking at decent conductivity. All right, so now I've done that part. I've done my solubility test. Again, I'm just recording these numbers, and in your procedure, you should say that. Here's what you need to record. Here's what you need to watch for. Right? One thing I didn't do when I did the solubility test was have a thermometer in here. Okay? But I did have my hand on the bottom, and this did get a little bit colder. Okay, when I dissolved it in the water. That's also something that you'll want to watch for. Now, because you have such small amounts of everything, you're only going to notice huge changes. Luckily, the ones that make changes make huge changes, and you'll actually be able to detect them as a change of about 2 degrees or so. I know that doesn't sound huge, but when you consider how little you're going to have, okay, 2 degrees in that little depression is a lot. All right, so watch for that. Okay. And then we'll do the pH test. All right, and we got just Hydrion paper here. I'm not even going to bother wasting it because that's pretty much neutral, that stuff. Okay, you can see that it's got a little color code chart on it. Oh, it's brand new. And I have to be smarter than the container, which apparently I'm not today. Oh, there's okay. All right, anyway, just to save time. Okay, you can see the color chart on there. I was just going to show you what the real colors look like because it's an orange container, but okay, you get the idea. You dip your pH paper in the solution and then just hold it up to the thing. And do that immediately because they do change as they begin to dry. Okay, so you want to check it immediately upon putting it in there. All right, are those all little details that you should include? Yeah, okay, so again, your procedure is going to be quite detailed. Right? It's going to be pretty long. That's why I'm giving you basically all of class today and some time tomorrow, okay, to get the pre-lab part written up. Now, it's not just the procedure I expect you to get written up today. It's also the hypothesis, the variables, okay, all of that kind of stuff. Everyone follow? Okay. All right, so this is a lab sheet you've got in front of you, okay, or essentially the same lab sheet you've got in front of you. All right, the problem we're investigating, okay, is given a bunch of unknown samples, right? How can we classify them as ionic, molecular, acids, and bases in order to find their identity? Okay, what are we trying to do in this lab? We're trying to find out what the identity of a bunch of unknowns is. Okay, we talked yesterday about what do you do with the problem. Okay, with the problem, you restate it in your own words in the form of a question. All right, so basically you have to find a way to say what we're doing in this lab, what we're trying to find as a question. All right, does that make sense to everybody? Okay, so what I don't want to see is that problem copied and pasted, okay, into your lab report. All right, for the design, we need to identify our manipulated, responding, and controlled variables. And this is the thing people forget. You need to explain your choices. Okay, so when you say this is the manipulated variable, you've got to tell me why. All right, are you changing it? How are you changing it? Okay, in the experiment. Okay, so that I know that you understand why it's the manipulated variable. All right, everyone understand? Right. Yesterday we talked about the plant growth experiment, and the manipulated variable was the amount of light. Okay, it was the manipulated variable because I, as the experimenter, determined how much light each of the plants would get, and light probably affects how they grow. All right, something like that. Okay, your responding variable, remember, is the thing that changes as a result of what you have done to the manipulated variable. Okay, and then your controlled variables are the things that you need to make sure you do the same for everything, or the same each time you run the tests, okay, or whatever in this lab. All right, so what are we manipulating? What is going to be different every time we run the tests in this lab? Probably, yeah. Okay, I mean, we've got a whole bunch of unknowns. They're all different. Okay, I'm not going to play a joke on you and put 12 different bottles of the same thing up there. Okay, that would just be cruel. All right, so I won't do that. So yeah, obviously that's going to be different, and that's what we're testing. Okay, responding variable, I'm going to let you guys decide what that's going to be. Okay, every time you run the tests, you're testing something different. Okay, so as a result, something should be different. Okay, you have to figure out what that's going to be. Okay, controlled variables, like we said, are the things that you need to make sure you maintain, okay, or do the same every single time that you run this experiment. You're going to run this experiment, okay, about 10 or 12 different times. All right, so you're going to have this spot plate, and you're going to run all those same tests, okay, about 12 times. Are there things you should do the same for each compound when you run those tests? Okay, those are the things that are controlled variables. When you identify them, you need to say to me, this is controlled because this is the effect it would have if it wasn't. Right? How many of those are we usually looking for? 3. Okay, so we are looking for 3 controlled variables. Obviously, there's only one manipulated, there's only one responding. Okay, but I'm looking, there are way more than 3 controlled variables, but you only have to identify 3, okay, and explain them. All right, so identify and explain all your variables. Now, for your hypothesis, what 3 words does a hypothesis need to have in it? Sadie. If, and then. All right. The premise we're working on in this experiment, I think you would agree, is that everything has its own unique physical properties. Would you agree? Okay. If that's the premise we're working on, what part of your hypothesis should talk about that? Probably. Yeah, it should probably be the if part. Okay? Because that's the premise we're working on. That's what we think the answer to the problem is. Okay? Is that going to, if that's true, will we be able to identify all of the stuff? Yes, we will. Okay? So the then part, we'll need to talk about that. Okay? The then part will say, here's my if, well, the hypothesis will go, here's what I think is the premise I'm working on, and here's what I'm going to do. Don't go into detail in your experiment. Just say something like, talk about the tests, not specifically, but just talk about testing physical properties or something like that, again, in your own words. Okay? And the then part needs to tell me what is going to happen and what is it going to allow me to do. All right? So in this lab, something's going to happen each time you test an unknown, okay? And it's going to allow you to do what? Okay? That's what you need to say in the then part of this hypothesis. Okay, for the materials on your version of this, they're already in there, so you don't have to do anything with materials. Okay, in the procedure, we've already talked about that. That's where you and your group members, okay, are going to write down the steps that you're going to follow. Okay, and it says down in here, make sure to conduct a controlled experiment. That is, do not vary the test between substances. Right, make sure you perform all the tests in the same way, okay, because that's going to be important. And be thorough in recording what you do, okay, and what you see. And again, in the procedure, make sure you tell them, here's what you should watch for, here's what you should record, okay, so that they know what kind of things to write down. All right. Okay, and then in the analysis, okay, I think I showed you that yesterday on the file you guys are going to get. Okay, it's got the, basically you just have to fill it in. Was A ionic or molecular, and what was it? All right, and then at the end you'll have your conclusion, which on your lab is blank. Okay, you need to restate your hypothesis by basically copying and pasting it. Okay, and then explaining using what happened in the lab, whether you accept it or reject it. Okay, and then for the evaluation, tell me any things that were trouble. Obviously, you're not going to be able to do the analysis, the conclusion, or the evaluation today or tomorrow. You're not going to be able to do them until at the very earliest Monday after class, okay? Because you won't have any data until Monday after class to analyze. All right? So as far as you can get, really, okay, is the procedure, all right, in the next day and a half. Okay? Are there questions so far? All right. So if you go into Google Classroom, all right, and you know, because obviously you're in this class, and this is my student identity as well. All right, this is what you'll see. Okay, I've just assigned, okay, the lab property, lab 1, properties of compounds. Okay, the description is lab to identify compounds based on their physical properties. Okay, the due date is September 18th. All right, that's next week on Thursday. All right. And the reason I'm making it kind of close to when we're doing the lab is because you're going to have half of it done before you even start the lab. So really, you don't have that much work to do after the lab. All right. Okay, so if we click on that, all right, so it'll open it up, same as always. Eventually. Okay, and okay, it'll have your name on it, and then you can open it up, and that's what you're going to be working on here today. Okay, you can type in your problem, your variables, your hypothesis, okay, and big part, your procedure. All right. Now, since you won't be able to take these into the lab with you, all right, you're going to need to have like a hand-drawn chart, or you're going to have to record your observations by hand, okay, in the lab with pencil and paper, pen and paper, and then transfer them into that chart later. All right, so you probably just want to make, for Monday, okay, a hand version of that chart, all right, so that you can record your stuff in the lab. Okay, questions there? Okay, I'll let you guys decide on who you want to work with, okay, and I'll make sure that everyone gets in a group. So if there's people who are new, okay, or whatever, we'll make sure everyone gets in a group. Yeah, and then we'll work on that. Now, one other thing I wanted to talk about, because last night I got a lot of emails, actually, from people asking about today's quiz. Just so you know, I don't normally, okay, give answers to quizzes. Okay, if you send me an email saying, Mr. Coder, you know, what's the answer to number 1, or you know, is this the right answer for number 3? I think I got that one a couple of times too. I'm not going to do that. Okay, my response is always going to be the same. Okay, it's in the podcast, or it's in your notes. Okay, if it's not in your notes, then you didn't write it down. Okay, and you just need to quickly go through the podcast again to find the answer. And that's, guys, I'm not doing that to be cruel. Okay, and I'm not doing that because I'm lazy and I don't want to tell you the answer. I'm doing it because I don't want to tell you the answer. Okay, I want you to look it up. That's the whole point of the quizzes, is for you to do some of your own independent review. Okay, and part of that independent review is looking in your notes. If you can't find it in your notes, I guarantee it's in the podcast. I would never put anything on a quiz that I have not said, okay, in class. All right, so if that comes up, okay, if it happens to you, just know, I mean, you can send me an email, but the answer might be no, okay? The answer might be go and check, all right? Because that's the whole point of those quizzes. So just so you know, I'm not being mean, okay? It's not that I don't like you or that I am really angry that you disturbed me or whatever, because that's not the case, okay? It's just that it's obviously supposed to be a review activity, and so I want you to do that, okay? All right, let's get to work and use our time effectively on getting the pre-lab stuff done today. Okay? If you have questions, let me know. Okay? Do we each need to hand in our own copy? Yes, you do, because that's the only way this works. Okay? You can't hand it in as a group because you each have to submit your own. Okay? The other question that came up is, can we share it with each other and work on it together? The answer to that is, let's not. You're sitting right here together. You can probably type each on your own and get pretty much the same thing written down. Okay? Plus, I don't know for sure, because I haven't tried it yet, whether you can actually share your individual document with somebody else, remember, you each got your own copy, and I'm not sure how that'll work if you try and share it. So let's just say, I mean, you're working together right now anyway. I understand they're going to be similar because you're working side by side. Okay, let's just make sure everyone does their own here, okay, and hands it in on their own. All right, because I have had in the past, you know, cases where it's been very obvious that someone has shared theirs with someone else, and that person has handed in someone else's work. Okay? And guys, I can tell that, okay? Because I can look back in the revision history of your document. Okay? If it took one person an hour and a half of working, and I can tell how long you've worked on it, okay? And before they handed it in, and the other person it took 5 seconds, I know you didn't do it. Okay? There's all these ways for me to find that kind of stuff out. All right? So just make sure that you're doing your own on there. All right? You don't learn anything by copying it from somebody else.